Alright, so in this lecture we are going to focus on the pH of a buffer solution. How do we calculate the different pH of a buffer solution? Now this is not something that is new to any one of us here, especially for the fact that we've done it in organic chemistry, first semester organic chemistry, where you calculated the Henderson-Heisenberg equation, and you also did it in biochemistry, I guess. Okay, no, it's the sciences that did it in biochemistry. So we are going to look at how to calculate the pH of a buffer solution. Now, how do we calculate the pH of a buffer solution, my dear students? It's very easy. Now, let's say consider a mixture of a weak acid and its salt. Now, if the salt dissociates completely, you are going to have Ma. If it dissociates completely, this is a salt, will be M plus and A minus. Now, if this is the acid, HA, if it dissociates, it's going to give us H plus what? A minus. Now, if we want to use equilibrium, right? Calculate the dissociation constant, acid dissociation constant, Ka, for the acid. It will be what? H plus and what? A negative divided by what? H A. The concentration of what? HA. Now, at equilibrium, one thing we can say is that let the concentration of the salt be the same as what? A minus. So A minus is the concentration of the salt, while HA is the concentration of the acid. Are you getting it now? Now, if we make H plus subject of the formula, how do we make H plus subject of the formula? Cross multiply. When we cross multiply, this will multiply this will give us Ka, and then you have Ha is equals to H plus and A negative. Alright? So that at the end of the day, make H plus subject of the formula by dividing both sides by what? A negative. Alright? Now, what do you think we are going to have? This A negative cancel this A negative. So, we are going to have H plus is equals to Ka Ha all over A minus. And then, if you take the negative log of everything here, you have negative log H plus is equal to negative log of everything in this bracket, right? You're going to give it negative log Ka plus, let's take the negative log of this group together. Are you getting it? So this becomes negative log Ha all over A minus. I've proved something like this to you guys before. Now, negative log H plus will give us what? pH, right? That is true. Negative log Ka will give us what? pKa. Are you getting it? Then plus negative log this group here, you can just put it at negative log, or plus and minus will give us minus. You don't need to put negative, you don't need to put it as pKa, pKha. Just write it negative log Ha all over A minus. Alright, so that is for the acid. Is that okay? That is for the acid. For acid, pH is equals to pKa minus log Ha all over A minus. Now, similarly for base, you also have the same thing for base. If you use the same formula for base, it's going to land you at pOH is equals to pKb minus, the difference is that for base, A minus will be on top, or you can say the base will be on top, while the salt would be under. That is just the difference between that of the base and the acid. While that of the acid, you have the acid on top and the salt under. This one also base on top, here is what? Salt under. Is that okay? So if you are giving pH, you use acid. If you are asked to calculate pOH, you use that of the base. All right, let's see a question. The question says calculate the pH of a buffer solution consisting of 0.1 molar solution of ethanoic acid and 0.25 molar solution of sodium ethanoate. How do we solve this? So you have 0.10 molar ethanoic acid, are you getting it, and 0.25 molar sodium ethanoate. Now my dear students, how do you solve this? They give you the Ka for the acid as 1.8 times 10 raised to the power of minus 5 molar. So what do? Calculate the pH. Now to calculate the pH, you use the formula pH, the formula you have to use is that pH is equals to pKa minus log acid over the salt of the acid. All right, so that at the end of the day, your pH now will be equals to, what is our pKa? Now this is Ka. To get pKa to be negative log of this value 1.8 times 10 raised to the power of minus 5 molar. If you press the negative log of this, here's my calculator. If you press the negative log of this, it's going to give you your answer. So you have negative log 1.8 times 10 raised to the power of minus 5. 4.74. So that is our pKa. So in place of pKa here, you put 4.74 minus log acid, the acetic acid, the molarity or the concentration of acetic acid was given as 0.1. So you have 0.1 divided by that of the salt, 0.25. So pH be 4.74 minus, then you have log 0.1 divided by 0.25, which is, this will give us a negative value. The negative value gave to us was minus 0.3979. Minus times minus will give us plus. So pH be 4.74 plus 0.3979, and then pH will be, if you 4.74 plus 0.3979, 5.14, right, approximately, or 5.1379, which approximate pH give us 5.14. Is that okay? So that is the pH of the solution, 5.14. All right, let's see the next question. The next question says 4.28 gram of ammonium chloride was added to 250 centimeter cube of 0.5 mole dm cube ammonium solution. Calculate the pH of the resulting solution. Kb for ammonia is this. Now we said calculate the pH, but you know that pOH, right, is pKb minus log base over the salt. Now in this question, the first thing you need to do is to identify the base and the salt. Now in this case, ammonium chloride is the salt, right, while ammonia solution is the base. We've explained something like this before in our subsequent lecture. Is that okay? Now how do we now calculate the concentration? Because you're already given the Kb. So if you are given the Kb, you can write out your parameter. Kb is 1.8 times 10 raised to the power of minus 5 mole per dm cube. What do you think pKb will be? It will still give us that 4.74, something like that. because it's the same thing as what we have, minus log 1.8 times 10 raised to the power of minus 5. 4.744, which is 4.74. All right, good. Now, the next thing is the concentration of the base and the concentration of the acid, of the salt. Now, which of them is the base? Ammonia solution. 250 centimeter cube of 0.5 mole per dm cube of ammonium solution. So how do we calculate the concentration? Now, recall, you learned this, that molarity, my dear student, molarity is number of moles all over the volume, either in dm cube or in liters. Number of moles over the volume, either in dm cube or in liter. Is that okay? So that at the end of the day, to get the molarity now for ammonia, it will be equals to, what do you think is the number of moles given? 0.5 mole per dm. Are you sure? If they already gave 0.5 mole per dm cube, it means we don't need, because that is the concentration of that is the concentration of the ammonia. Are you getting it now? So we don't need to go through. The concentration of ammonia was already given as, you sure? Yeah, concentration of ammonia was already given. All right, so we can say concentration of ammonia is ammonia concentration, which in this case is the base, was already given as 0.5 mole per dm cube. Now we can also use this volume you have here to solve for the concentration of ammonium chloride. We can use this volume you have here. This is the volume, because apparently this is the volume of the buffer. So let us calculate the concentration of ammonia chloride. Now, this is 4.28 gram. How do we calculate concentration? We say molarity is number of mole. From the formula I just gave, molarity is number of moles all over volume. Number of moles, on the other hand, is mass over molar mass. So number of moles, what was the mass of ammonium chloride given? 4.28. What is the molar mass of ammonium chloride? Ammonium chloride is NH4Cl. Nitrogen is 14, hydrogen is 4, 1 times 4 is 4 here. Chlorine is 35.5, which is 18 plus 35.5, which is 60. Are you sure? Yes, 53.5. So you have it as 53.5 gram per mole. This is gram. Now, at the end of the day, what do you think we can do here? This gram, we cancel this gram. When this divide this, our number of moles will be equals to 4.28 divided by 53.5. That will give us 0.08. All right. So that will give us 0.08 mole as the concentration of the number of moles of ammonium chloride rather. Now, sorry about that, there's no enough space for us to continue. Let me just erase. Okay, we've already found this, so I can erase this part. We are supposed to have another space to write on. So this is the concentration of the number of moles of ammonia chloride or ammonium chloride. Now let us calculate the molarity of ammonium chloride. Molarity, we said number of moles over volume. Number of moles is 0.08. Volume, I told you that we are going to use the volume of the solution, which is 250 centimeter cube, but you have to convert it to dm cube. So you divide this 250 by 1000. You divide the 250 by what? 1000. So when you divide 250 by 1000, it's going to give us 0.25. So the molarity, which is the concentration of ammonium chloride in solution, will be 0.08 divided by 0.25, which gave us 0.32. So the concentration of ammonium chloride or ammonium chloride, which is the base, is 0.32 molar, which is also mole per dm cube. Is that okay? Now, we already got our pKb and every other thing. So let us calculate our pOH first. So pOH, pKb is 4.74 minus log, let me take it a little bit this way. So pKb is equals to pOH rather, is equals to pKb is 4.74, right? Minus log, the base in this case now is ammonia. What was the concentration of ammonia given in the equation? 0.5 divided by, what was the concentration of ammonium chloride we calculated? 0.32. So our pOH will be 4.74 minus log, oh yeah, now press log 0.5 0.32. Now this gives us 0.19. So our pOH will be 4.74 minus 0.19. So minus 4.74. This gives us 4.55. Alright, so that's our pOH. But everybody knows what we were asked to find was pH and not pOH. I will know the relationship between pH and pOH. We said pH is equals to 14 minus pOH. True or false? True. So our pH now will be 14 minus pOH is 4.55, my dear students, which is going to give us 14 minus 4.55. That will give us 9.45. And that was how you got the 9.45 in the material. It was actually given. Alright, let's see the next one. Calculate the pH of a buffer or of a buffer whose HA, that is the acid, concentration of the acid, was given as 0.1 mole per dm cube. The concentration of the salt was given as 0.1, the same thing, mole per dm cube. The Ka was given as 2 times 10 raised to the power of minus 4 mole per dm cube. Now there are different ways you can actually calculate this. First of all, you may decide to calculate the H plus ion and then find the negative logarithm of the H plus ion, or just go straight and calculate. Now according to your material here, they actually calculated H plus first, then found the negative logarithm, but you don't need to do that. Just put your pH formula is what? pKa minus log acid over salt. How do you calculate for the pKa? pKa is minus log of Ka. Ka is 2 times 10 raised to the power of minus 4. So what do you think your pKa will be? So you press calculator, minus log 2 times 10 raised to the power of minus 4, which is 3.698. So this is our pKa. So we can now say that our pH Now, for you to have known that the concentration of the acid is equal to concentration of base, just know that your pH will be equals to pKa. When the concentration of not base, conjugate base, or the salt, when the concentration of the acid is equal to the concentration of the salt, pKa is always equals to pH. So in this case, if pKa is 3.698, it means our pH also will be 3.698. Now that is only possible when these two things have the same concentration. Now how do you prove that? pH now will be, formula pKa is 3.698 minus log acid is 0.1 divided by 0.1. Alright, now at the end of the day, when this cancel this, you have 1. Log of 1 is what? To give us 0. Are you getting it now? So pH will be 3.698 minus 0. pH will be 3.698. Is that okay? So that will be the pH of that solution. It's kind of very easy, right? Let's see the next one quickly. I know I'm done. Okay, I think that is all for this session. We'll see you in the next one.